Yesterday we talked about solubility, and that's basically just how much stuff you can dissolve into a certain amount of solvent. So solvent is the thing that's doing the dissolving, and a lot of times the solvent is going to be water. One thing you can change is temperature. So we talked about yesterday that if you want your tea to be really sweet, if you make it hot tea, it's going to be a lot sweeter than cold tea because you can dissolve more sugar into hot tea than you can cold tea. So for temperature, if you're dissolving a solid into a liquid, the solubility will increase as you increase the temperature, meaning that you can dissolve more if it's hotter. So for solids, the hotter it is, the more you can dissolve. However, it's backwards for gases. So if you're trying to dissolve a gas into a liquid, like a carbonated drink, so like soda, the colder it is, the more carbonation you can put into it. So it actually is true that if you have a cold soda versus a hot soda, you can dissolve more CO2 into the cold one. And so it's going to be more bubbly than it would be for the hot one. So for solids, you can dissolve more if it's hot. For gases, you can dissolve more if it's cold. Another factor is pressure, but keep in mind that pressure doesn't really affect solids and liquids very much, just because they're already so close together that you just really can't press them together anymore, so pressure doesn't have a whole lot of effect. But for gases it does. So if you wanted to make your soda carbonated, you have to actually press the gas into the liquid. It's not going to go in there by itself. And the more you press it, the more gas you can put into it. So solubility will increase if you increase the pressure. But again, that's only for gases. So today we're going to do two equations. And the first one is molarity. And what I want you to do is circle the word concentration and the word molarity. Because in the question, it's going to say, what is the concentration? You need to know that anytime they're asking you for concentration, they're asking you for molarity. You need to know those two words simultaneously. And molarity has an equation that's going to be in your reference packet. So this second bullet where it says molarity equals moles over liters, that's in your reference packet. You don't have to memorize it. And the symbol for molarity is a capital M. The problem is you're not always given moles and you're not always given liters. So if you're asked to calculate the concentration or the molarity, you have to have moles on top and you have to have liters on bottom. So if they give you grams, you cannot put grams over liters to get molarity. What you have to do is first convert the grams into moles. And you know how to do that now, you just have to use the periodic table. So set up a little fence post, convert your grams into moles, and then plug that into the molarity equation. Same thing for liters, you have to have liters on the bottom of the fraction if you're solving for molarity. You cannot have milliliters. So if you're given milliliters, you need to convert it using this conversion factor, that there's 1,000 milliliters into 1 liter. And if you have trouble solving for the bottom of a fraction, a lot of times you're going to have to solve for liters. You can put molarity over 1 and then cross multiply, and that will get rid of your fraction for you. Let's try a couple. The first one says, what volume would have to be used to make a 3 molar solution with 5 moles? So molar means molarity, and moles obviously means moles. So here's our equation. We were given the molarity, which is capital M, and we were given moles, which is MOL. So if you plug in 3 for capital M and 5 for moles, all you have to do is solve for liters. And just be careful with your math. A lot of people have trouble solving for the bottom of the fraction. So again, if you don't like the fractions, put the 3 over 1 and then cross multiply. So you have 1 times 5 equals 3 times x. Just like this. And then just make sure you divide the right way. To get rid of the 3 over here, you need to divide both sides by 3. A lot of people end up dividing wrong and they'll do like 3 divided by 5, so just be careful that you set it up correctly. And that's your volume, 1.67 liters. Let's try another one. This one says if you have 20 grams of magnesium hydroxide dissolved in 500 milliliters, what is the concentration? So again, notice that they're asking you for concentration. You need to know that when they use that word, what they're asking you for is molarity. Once you know they're looking for molarity, you can look up this equation in your reference packet, and you know that to get molarity, you need moles and you need liters. Well, the question doesn't give you either one. So first we're going to start with that 20 grams. We can convert that into moles. We just need to use the periodic table. So if you add up 1 magnesium, 2 oxygens, and 2 hydrogens, you should get about 58.3. And set up your little fence post, make sure your units cancel. So since you're starting with grams, you want to bring grams down. And that will turn it into moles. So now we have the top of the fraction. We need liters on the bottom, and they didn't give us liters, but they did give us milliliters. So again, set up a little fence post so you can decide if you need to divide or multiply, and calculate it. So now we've got moles, and we have liters. So all you have to do is plug it in and calculate the molarity. Moles goes on top, and liters goes on the bottom. And if you want to practice some more molarity problems, worksheet number 2 in your reference packet should have all of the answers on there so you can check as you go. So try some on worksheet number 2. The second equation we're going to do has to do with diluting something. This is just a little cartoon. So if we say 5 molar solution, we're talking about the molarity is 5. This one has molars as in teeth. I know, it's pretty bad. Let's move on. When you're making dilutions, you're always going to increase the solvent. You could technically take out the solute particles, all the little red dots, but it's really hard to take them out once they're dissolved into water. So it's much easier just to add more solvent, and that dilutes it. And when you're doing a dilution, this is the equation that you're going to use. M1V1 equals M2V2. And this equation is also in your reference packet. Capital M stands for the molarity, and V stands for the volume. And the volume does have to be in liters since your molarity is also in liters. So let's try a dilution problem. It says a chemistry teacher needs 6 liters of 2 molar HCl, but in the stockroom you only have 5 molar. So you're going to have to dilute it down to 2, and they want to know how many milliliters would you use to dilute it. So you always want to match up the numbers that go together. So you see how 6 liters of 2 molar, so the 6 and the 2 need to go together. And then you have 5 molar, and you don't know how much of that you need, so 5 goes with X. It really doesn't matter which side of the equal sign you have them on, as long as you have the 2 with the 6 and the 5 with the X. Solve for what you're missing for, so in this case we're missing the liters. And then just be careful because this question asks you for milliliters, so you just need to convert it at the very end. So for dilution problems, you'll get 3 out of these 4, and you just have to solve for the 4th one. And this was actually a bumper sticker that I've seen before. The real one is, if you're not part of the solution, you're part of the problem, but this is a chemistry joke, because if it's not part of the solution, if it's not dissolved, it means that it's a solid, which we call a precipitate, but most people wouldn't know that word. Last thing for today is colligative properties. Colligative properties depend only on how much stuff you have, not on what chemical you have. And notice what's in capital letters and bold. So when you see colligative properties, you need to think how much. Make sure you circle that or underline that. Most properties in the world, it matters what chemical you have. So for example, if I wanted to know if something is flammable, well, it depends on if you have paper versus the suit that a fireman would wear. If I wanted to know if something is red, well, it depends on, are you talking about a strawberry or a blueberry? So it depends on what chemicals are in the thing. Colligative properties are different because it doesn't matter what chemical you have, it's only about how much stuff you use. And what I mean by that is, for example, vapor pressure lowering. Remember, vapor pressure is that little pocket of gas right on top of a liquid. So if you had a puddle of water, right on top of that water you would have a little pocket of gas as the water evaporates. That's called your vapor pressure. If you have 100% water, all that water is evaporating, so you have a high vapor pressure. But if you sprinkle something into the water, and again, it doesn't matter what it is, it could be sugar, it could be salt, it could be sand, if you just sprinkle something in, not all of the surface of the water is evaporating, and so it goes down. So the vapor pressure would go down the more stuff you add. And the key is that it doesn't matter what you're adding, it's how much stuff you add to it. Osmotic pressure would go up, and you don't need to worry too much about that one. I haven't seen a whole lot about that. Just realize that if you add particles to a solution, the osmotic pressure would increase. Freezing point depression is a big one because it has to do with the reason why we put ice on the roads. So the reason we do that is because it forces the freezing point to go down. That's what depression means. So instead of freezing at 32 degrees Fahrenheit, the ice would freeze at a colder temperature, so say 25 degrees. So as long as it doesn't get down to that new colder temperature, the water is not going to freeze. It doesn't mean that it's never going to freeze. So a lot of people think if you put ice on the roads, it keeps it from freezing. It doesn't actually keep it from freezing, it just makes it harder for it to freeze. So it has to get to a colder temperature. And the last one is boiling point elevation. This has to do with adding salt to cook spaghetti. So a lot of people will tell you that if you put salt into your pot of water, it makes the water boil faster. And that's actually exactly wrong. That's not what happens at all. It actually takes longer for the water to boil because it raises the boiling point. So instead of boiling at 100 degrees Celsius, it might boil at, say, 110 degrees Celsius. So it takes longer for that water to get up to 110 and start boiling. But once it starts boiling and you put your spaghetti in, it's going to boil at 110 degrees instead of 100, and so your spaghetti will cook a whole lot faster. So adding salt to the water does make the whole process faster, but it actually doesn't make the water boiling faster. It takes longer for the water to boil. So what I want you to do is put a down arrow for vapor pressure lowering, put an up arrow for osmotic pressure, a down arrow for freezing point depression, and an up arrow for boiling point elevation. So for vapor pressure and freezing point, the more particles you add, the lower those two things are going to go. And for osmotic pressure and boiling point, the more particles you add, the higher they're going to go. And that's it for today. I want you to try some on worksheets 2 and 3. Worksheet 2 is all about molarity, and worksheet 3 is about dilutions.